Why waste time in commute and spend lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.
Hello students, welcome to the POIQ discussions on JEE Advanced paper. Here I have got a problem from JEE Advanced paper 1 2023. The question says list 1 shows different radioactive decay processes and list 2 provides possible emitted particles. Match each entry in list 1 with an appropriate entry from list 2 and choose the correct option. So you can see this is the list 1 where different decay processes are given here, and in the list 2 you can see the emitted particles, radioactive particles, alpha, beta, and numbers also are given. So how many beta, how many gamma decay can occur in each process, you have to find out that. Okay, so after matching that you have to choose the correct options from this. So this type of question actually carries 3 marks. Okay, so you look here, this problem is actually the most simplest problem in this paper 1, because you know this is from alpha and beta decay, which is very simple. Suppose a nucleus X is undergoing, suppose it has Z atomic number, or we can say the number of nucleon, number of proton. Z is the number of proton and A is the mass number. Okay, and it is undergoing a decay. When this emits alpha particle, then what happens? Alpha particle is nothing but nucleus of helium. Okay, nucleus of helium atom. So nucleus of helium atom has 2 protons, or charge 2, and mass 4. Okay, mass 4. Then when one alpha particle comes out of this, then what happens? You look, if I just write this reaction, suppose one alpha particle is coming out, then see, if alpha particle comes out, then charge will be reduced by 2 and this mass number will be reduced by 4, because this alpha particle has charge 2 and mass number 4. So I'll get some other nucleus which has proton number Z minus 2, because it is alpha particle has 2 charges, and mass number will be A minus 4. Mass number will be actually reduced by 4. If suppose just after this alpha decay, one beta decay also happens, then what happens? Suppose that is some other nucleus again, or maybe I can keep the same nucleus itself, that you take some other nucleus. Let us take that as some P or something. Okay, if one beta minus decay means, you know, effectively nucleus will gain one positive charge, it will effectively gain one negative charge. So I was here, see, I was here after alpha decay, I was here, and it was A minus 4. Now if one beta decay happens, beta particle is nothing but nuclear, you know, that electron. So electron has negligible mass compared to proton and neutron. So we'll think that there is no change in the mass number if one beta decay happens. But since one electron is going out, effectively it will gain one charge. Okay, then, you know, it was like this, plus 1 will be the charge. Okay, then effective charge or effective proton number in the nucleus will be Z minus 1. If further beta decay happens, that means, see, one alpha decay and back to back one alpha decay followed by 2 beta decay. See what happens then. If this happens again, another beta decay, so mass number remains the same. Okay, A minus 4 itself, but see, Z minus 1 it was, so it will actually gain one more positive charge in the nucleus. So effectively it will have the proton number Z minus 1 plus 1, so it will be Z itself. Okay, this is one situation with beta minus decay. Suppose, see, alpha decay, at alpha decay, you know, alpha decay, after alpha decay we have got A minus 4 and here Z minus 2. Now if further one beta plus decay happens, that means it is kind of positron. Okay, kind of positron you can say, or antiparticle. So beta is negative particle and antiparticle of that is beta plus. Okay, beta minus and beta plus. Okay, this kind of positron. So you just think that antiparticle of this beta minus, that means, say, in case of antiparticle, mass remains the same, only the charge changes. Okay, in case of antiparticle, charge actually will be reversed but mass remains same. So in case of beta decay, you look here, since one positive charge is going out, so it will lose, the nucleus Y will lose another proton, so it will be actually becoming some other nucleus with different mass number. And say if I say this is P, so this will be, the mass number remains the same as it has very negligible mass, beta plus, and this will actually lose one more positive charge. Okay, so it will have Z minus 3. So this is the concept here. Now we have to check the reactions here or decay processes here. See, in this case, see how is the mass number changing? The mass number has changed to 238 it was, so minus 4 means, so 234. Okay, that means you can understand that there was an alpha decay, so one alpha decay has happened, that's why this mass number. See, mass number does not, see, mass number changes by 4 that I told, and then the proton number would have changed by 2, but here it is changed by 1. See, 92 to 91. That means one beta decay has happened. Okay, so after alpha decay you should have 90. Okay, number of proton should be, or Z should be 90, but it is plus 1. So that means beta minus decay has happened, one beta. So if I write this reaction, so I'll just write side by side. I hope you have understood this, nothing much in this. Okay, so I'll write one by one. Look here in this case, so one alpha decay and one beta decay, beta minus decay obviously, because one positive charge has been gained. okay, or has been increased. So one beta decay, beta minus decay. So we have to see where one alpha decay and one minus beta decay. So actually P is matching with 4, you can see that. One alpha particle and one beta minus particle. Now go to this Q. So here also you can see the mass number has, see, it was 24 for PB, okay, and it was 82. Now see, mass number has changed to 210, PB 210. That means one alpha particle, that I can say sure, okay, I can say surely. And see, Z is not changing. That means what is happening? Back to back 2 beta minus decay is happening, okay. So by first alpha decay, 822 minus, so Z will be 822 minus 2. So you should have got 80, but you are getting 82 itself. You look this Z. So what is happening? Back to back 2 beta minus decay. So 1 beta minus decay, Z becomes Z plus 1, okay, okay. Here Z was 80, so Z becomes Z plus 1, that means 81, and by another beta decay you will get another plus charge added here, okay, so you will get 82. So here for the second decay process, what is happening? There will be one alpha particle and 2 beta particle, beta minus particle obviously. So you look where 2 beta minus particles. So this is the beta minus particle and 1 alpha particle. So this is matching with 3, okay. Now look this R. Here mass number as usual, see, changes by 4. So 1 alpha particle I can say, but see here it was 81. So after alpha particle, see, I'll write the reaction here. Helium 81. See, alpha decay happens. So I should have got, see, now I have got PB here. So I'm getting 206 as the mass number, okay, and Z I should have got 79, okay, because proton number will be reduced by 2. But what I am getting here, you look, see, I am getting 3 extra. So these 3 will come from beta minus decay. So back to back 3 beta particle will be emitted, okay. That means 3 beta particles, okay. 3 beta minus will go such that you will gain plus 3 charge in the nucleus effectively. So it will be 3 beta minus decay, okay. So look here, 3 beta minus and 1 alpha particle. So similarly, now I should not answer the last one, I will leave for you. Is it okay? Yeah, still we will discuss. Let us see how we get. See, 228, now it has become 224. That means 1 alpha particle, that I can say surely. And see, it was 91. So minus 2 means you should have got 89, right? 89. Instead you are getting here. So after 1 alpha decay, you should get Z 89 and mass number is 224. But see, mass number is okay. That means 1 alpha particle decay has happened. And see here, it is reduced by 1. That means, you know, 1 beta positive, okay, beta plus decay has happened. So that effectively 1 more positive charge will be going out and you will reduce another positive charge in the nucleus. So here 1 beta plus decay, okay. Now see this, how it matches. So this matches with 1 alpha particle, 1 beta plus C, this 1, option 1. Okay, then see what we are getting. See, P is matching with 4, then Q is matching with 3, R is matching with 2, and S is matching with 1. Okay, so let us see P4 Q3, P4 Q3, R2 and S1. So option 1 will be the, like option A will be the correct answer for this question. Okay, so this is the answer for this question. Thank you.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology, for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com, contact 99402 49720.